Hey, what's up, guys? Today we'll see what is lift and drag, basic aerodynamic forces, right? So, what is lift? First, understand the aerofoil shape. This shape is known as an aerofoil shape, which creates the maximum amount of lift. Now, what is the lift, right? If you say you have airflow passing through these certain kinds of shape, a specific shape that we call this shape airfoil, right? Now what happens when the air or any fluid flow from this specific shape? It has cambered shape on the upper side and little bit flat on the downside. What happens? The airflow or air particle, which are these are the two sections, right? Now air particles at upper side are comparatively moving faster than the lower. So as per the Bernoulli's equation, what happens? The air particles are here on the top of the aerofoil are moving faster. So comparatively moving faster, velocity is high, so pressure is low. And opposite, they are moving slow, low velocity, high pressure. It means it has created two zones, high pressure zone and low pressure zone. Now as we know that the any object go from the high pressure to the low pressure, so it lifts up the shape or this object on the upper side because this is the high pressure zone, and this force is known as the lift. Now let us see this on the simulation mode. I have okay, right. Now see what happens. This is our airfoil shape and this is our airflow. Now you can see this. Here particles are moving faster and here particles are moving but little bit slower. So this creates the upward direction, force in upward direction, that known as a lift. It is now you can better visualize the airflow pattern over it, and as you use the inclination, your value of your lift will be increasing, right? Your pressure, see, now you can also see what is the pressure difference over with respect to places. What is the pressure difference for that? Let us reduce little bit of speed. Now this is the air particle that I have discussed earlier. You can see it very easily, and this is the speed where it is. Okay, so you can see these are the air particles which are moving comparatively faster with respect to this, and this creates a low pressure zone and this creates a high pressure zone that will give lift upward direction, force in upward direction, that is lift. Now let's see the equation of the lift. The equation of lift is equal to 1 by 2 CL, where CL is equal to coefficient of lift, right? And rho is air density and V is a instantaneous velocity at any certain point where you are finding a lift, and 1 by 2. Now this formula is very similar to the kinetic energy of any material, half mv square. Same, here we are taking mass, here we are taking rho. Because we are discussing about fluid, that's why we are taking mass per the unit volume. Volume same, 1 by 2 same. We are just adding Cl. This is the coefficient of lift. As you can see, it is a coefficient. It doesn't have any dimension. This is Cl. This is Cl, coefficient of lift. It is a Cl, so you know it don't have any dimension. So it is basically just a numerical value. It has just a numerical value, so doesn't matter for that. I mean, for the formula point of view or from the dimension point of view, it doesn't matter what it is. So here it is. Now come to the track. As you can see from the microscopic level, the shape of aerofoil, it is not exactly and very smooth. It is something like that. Hills and valleys are there. It is very rough surface. So what happens? Air particles are get stick here, and that creates an vortices, or just stick there, and these will create a friction on its skin or its outer layer. Something, this is your like wing of your aircraft, right? So here is an area. This whole area, this create a skin friction, and due to this friction, the one force which acting in this direction, backward direction, known as drag. It is a simply a air friction, but cumulatively we are giving it as a new name, that is drag force. Now the formula of drag force is also same, 1 by 2 Cl, 1 by 2 rho v square Cd, coefficient of drag, rho air density, v is equal to velocity, and 1 by 2 same as the kinetic energy, 1 by 2 m v square. In the place of m we are putting rho, in place of Cl we are putting C d, because it is a drag. So that's it. uh, I hope you like the video. So thanks for your kind attention watching it. Thank you so much, and don't forget to like, share, subscribe on video, and share it with your friends if you like it. And thanks.